Many businesses start by building apps and architectures that seem to be right choices for that time, but after a while fail to meet scalability and response time requirements of a growing business. I'd like to welcome Trevor Martin, a solution architect with Redis, to take us through such a journey where Redis Enterprise came in to help get that online business back on track. Trevor, please take it away.
Hey everybody, my name is Trevor Martin, and I'm going to be giving a demo today called Boosting Retail Performance and Fueling Global Expansion. We're going to showcase a few key features and differentiators of Redis Enterprise throughout this demo as we go through a hypothetical situation. A little bit about myself. I'm a solutions architect here at Redis. I've been here for about 2.5 years, and in a previous life before Redis, I was working at Oracle for about 3.5 years as well. So have experience in both the SQL or relational database world as well as the NoSQL space. Today, I'm going to demonstrate the power and simplicity of Redis Enterprise as a real-time data platform and a front-end database. Most solutions architects and developers have experienced this journey where you are building an application on a disk-based database, and then you ultimately will face performance issues as the system grows and expands, and you have to decide how to address this and solve these problems. So in order to give this demo, we're going to basically talk about a hypothetical situation. So Meet Fashion, they are a brick-and-mortar clothing retailer. They're based out of New York City, and ever since the pandemic, where there's been a much larger focus on the digital world and an online presence, that has been a big focus for fashion and the group here that does manage the e-commerce site. For starters, our current state architecture looks a little bit like this. For one, I'll first cover some of the issues they're facing on the left-hand side. Again, they were built off of a SQL database from the beginning. It's actually Postgres in this case. They're running into scaling issues when it comes to the number of users they have during peak load times. Queries can take anywhere from 1 to 2 seconds, which is of course unacceptable in the modern day. And furthermore, inventory counts have been off, and as a result, many shopping carts have been abandoned. So clearly a pretty big problem here. We're losing customers, have a subpar experience on the website. So we definitely need to take a look at this and try to address it. Currently, there actually is a little bit of Redis open source usage for collecting stream analytics. And so really what this is telling us here is, there are latency spikes around their peak hours. If you take a look at the graph on the right-hand side, it might be hard to see, but in the peak times, we actually have latency of up to 4 seconds. And in the best case scenario, it's still about 1 to 2 seconds, as we've kind of described earlier. Secondly, beyond the performance issues themselves, the search experience itself is actually not up to par either. And we'll take a look at this here in just a brief moment on the actual website, but the expectations for a website with the search capabilities have evolved as time has gone on. And in particular, users want to be able to search based on categories. We might want a certain brand within a price range, a certain color, maybe a certain style of clothing, whether it's a t-shirt or a formal shirt. So this is pretty much par for the course, an expectation for how a website should behave currently. So we'll take a quick look at our e-commerce site. Here's a brief tour around. We have some trendy products on the home page, but as a user, I'm coming to this site and I have something particular in mind. Not exactly sure what I want, but if we start off with a shirt, we come here and we'll notice that it's a wide variety. We're definitely seeing shirts, but the results themselves are quite all over the map. So this leaves more to be desired when it comes to these different capabilities. Again, this is the e-commerce site that is running off of Postgres, and so it's a disk-based system. We have here within our console a peek at the latency. Currently, we're at about 179 milliseconds of latency, and so this is clearly not ideal. The performance here isn't so bad, but again, we're not actually during the peak hours. We'll take a quick look at our own latency metrics here of this site real time, and we can see there's actually a decent range of latencies depending on when we're accessing, and when it comes to the total round trip from end user to the database and back, we have latencies that can be 1 to 2 seconds. So jumping back into the deck here, this leads to some architectural questions, and as a solutions architect, as a developer, you really have to take a look at this and try to understand all the factors that go into providing a solution and fixing this issue. So typically in the classic approach of adding a search engine to a relational database, it involves a couple of different factors and different services that will be required. To start here on the left-hand side, a CDC product, something like Debezium, will be necessary alongside a sync connector for this CDC product to capture these changes that we are seeing in our relational database. It could be a change in inventory. Maybe we sold out of a product. Maybe we changed the price of a product, added a new product. So all of this needs to be accounted for, of course. We don't want to have customers purchasing something that we don't have in inventory that will lead to a bad experience. So there's the CDC portion of it. We need to stream these changes over. This also needs to be a very scalable system as well, as we could have many requests coming in. This would be something like Kafka, for example. And these streams are taking these changes that we captured from our source database into an event processor. And finally, this is where we're going to potentially denormalize the data, transform it to a specific format for the search engine, for example. Search engine can be something like Elasticsearch, Apache Lucene, kind of in the classic approach. But as we'll find out here in a second, Redis Search is actually a great fit for this as well. So we've talked about sort of the classic approach and how things can typically be solved traditionally, but Redis Data Integration is actually a product that the solutions architect team here at Fashion came to know, and this is actually a great solution that's going to simplify their architecture and solve these problems at the same time. So a little bit about Redis Data Integration, or RDI as we call it. It is an out-of-the-box data integrator connector, basically, for relational database systems. We can capture these changes just like a CDC tool. It actually involves a CDC tool within the solution itself. And we have a variety of different out-of-the-box connectors for Postgres, Oracle, MySQL, SQL Server, Percona ExtraDB, MariaDB, and there are actually more to come. So have these out-of-the-box connectors to capture changes from all of those databases. Any transformations that we need to be done, that can be done very easily with the out-of-the-box capabilities of RDI. And so this solution really does lend itself to solving these problems. And the great part about Redis Data Integrator is that it, of course, runs on Redis Enterprise. And in particular, we can also have Redis Search, which will be our search engine, running on Redis as well. So there's a lot that could be said about Redis Search, but for today, we're mainly focused on the fact that it is a out-of-the-box search engine. It's built off of the native data structures within Redis, and it's not only going to boost the performance of our search capabilities, but we're also going to be able to improve our actual search capability and the features of it, as we'll see here in just a moment what the site will look like as we turn on these features here. So to take a quick peek back at our website, we're going to come in here and simply turn on Redis Data Integration. And this will do two things. For one, we're going to see that our faceted search, or our search features here, are actually a lot more user-friendly. We can come in here. These are still the results for a shirt. Now, in particular, I'm looking for a red shirt, we'll say. We're looking for a men's shirt, and we'll say more of a sports shirt. So these results are exactly what we've described here. It's making for a better experience. I knew I wanted a red shirt, wasn't exactly sure which one I wanted, but we're able to provide the user with what they're actually looking to potentially purchase. And so not only is the search functionality better, but we should also be seeing a great improvement in our latency here, as we are now at 15 milliseconds. And the reason for this is that we're now actually running our queries against Redis as opposed to the Postgres database. So at the very highest of levels, it's an in-memory database versus a disk-based system. So there is the performance benefits there, but it's also much closer to the application. We'll oftentimes see single digit or sub-millisecond latency. And so we've seen quite a few benefits alone with just adding Redis Data Integration as well as Redis Search. So I know we've talked a little bit about Redis Data Integration and what it can do, but we really haven't seen that in action quite yet. And just to go through, what we've talked about so far, we've talked about these architecture changes at a high level. And one of the key advantages really is that Fashion, the company, is able to continue to use their SQL database. There's no need to rip and replace, make many changes. It was a subpar system that was having performance issues and scaling issues, but we introduced Redis essentially as a front-end database, search engine, and we are integrating with our back-end system of record with Redis Data Integration. So not many architecture changes. In fact, it simplifies the architecture, especially as we compare it to the classic approach of adding all of those other components. And so we end up with not only the solution for the problem, but we've also simplified our architecture at the same time and eased our operations as well. So now what we're going to do is actually show Redis Data Integration in action. This is an example query. We're going to do one that's slightly different, but it's roughly the same. So we have our SQL client here. And essentially what we're going to do is, let me first and foremost open up our search engine here, and we're going to open up these results here. So we have the accessory gift set, essentially a tie with some cufflinks and I believe a pocket square. So as we take a look here, we have these different accessory gift sets, and we'll have a query run on the back end, which will change the price to be on sale. And as we see here, we are now on sale. And so really just showing the instantaneous changes that are going to be propagated over from our system of record, which is again Postgres database, to our front end, which is of course querying from our Redis search engine. So just a quick example to show the power of Redis Data Integration. And this can obviously work with all sorts of product updates, whether it's price, a description update, title update. We might add a new product, we might remove a product. And so the possibilities are truly endless, and we can definitely account for all of those major changes. Now, we've solved a lot of these problems, and we've been smooth sailing for a little bit. What we've started to notice here with our team at Fashion is that they've started to get a lot of orders coming from Europe. And so that's great news for the company, but at the same time, it's a bit of a risk because now we have new customers coming in. We're only deployed in the United States, is what Fashion is saying. And so they're not going to have the best experience when they go to our website. And so we have another instance of our website here. This one is being accessed from Europe, as we can see here, from the web server in Europe, essentially. And so our database latency here, we can see is very high, 4.5 seconds. So that's obviously unacceptable. So when we take a look here, Active-Active is a feature with Redis Enterprise that essentially will solve this problem. In short, Active-Active is a way to have geo-distributed databases. And so we can have our search engine that we've talked about already that has our product data, our catalog data. And this essentially can be mirrored or synchronized with another copy that is locally close to these other users. So we can have our US instance, and we have a database instance in Europe as well. And there's going to be a synchronization process across these different sites. So what we'll see here is with Active-Active, we're going to have multiple databases that are representing the same set of data. So in the US, we will have our search engine that we've already talked about that has the product data. And we essentially can deploy an instance in Europe that will be synchronizing with this other database in the US. So it will be also accurate when it comes to the product details and all of those different functionalities. The key differentiator is our users in Europe will be able to access that local site that's within their region. And so they'll have local latency and will definitely benefit their performance overall. So to take a look at this, we won't be able to show the queries as much because I am located here in the US, but as we turn on Active-Active, this is essentially deploying that database in the Europe region. And so a user that is hitting the web server out there will see a greatly improved latency here. It went from about 4,500 milliseconds to about 8.72 milliseconds. And so great improvements there when it comes to the actual performance of the database. These new users that we have in Europe, they're going to have a much better experience because they have local latency. And they're, of course, going to see the same benefits that our other users did in the US with our improved search engine and overall performance. Just to take a quick look at the architecture here, there's a lot going on. It's similar to some of the components we saw earlier, but most importantly, we have a synchronization process that is occurring across these regions. And whether we have concurrent write situations or multiple read situations, we can account for all of these different changes with a predictable model. All in all, Active-Active will be able to accomplish the synchronization across the different regions and provide that next level experience for our users, our new users in Europe, so that they can also have a good experience with the website and ultimately make purchases and try to really drive that revenue as we start to expand into other regions. When it comes to this diagram, there's a lot going on. It's a lot of the stuff we've already talked about with Redis Analytics, looking at our different latencies for our users and our user experience. We have Redis Data Integration, of course, propagating our changes from our system of record, Postgres database. And we also have the actual synchronization across regions, which is making sure that our European copy that is deployed in that Europe data center, that region in the cloud, perhaps, is essentially up to date with any changes that might be made on either side. So all in all, to sort of bring it all together, a couple of problems we solved. We improved customer experience with the built-in search engine and had instant query response. We also replicated the data store globally with Active-Active Geo-Distribution by also providing resiliency and local performance for these users as well. And then really maybe the unsung hero or maybe the underrated aspect is that while we solved all these problems, we were able to continue using the SQL database for Fashion, that Postgres database, while still achieving the real-time performance. So didn't need to rip and replace. We added some complementary components that solved the problem, but it also very much simplified the architecture when we look at the alternatives of building out a search engine as well. Thank you guys so much for joining. Feel free to reach out if you have any questions. We can definitely be here to assist, whether it's questions about this demo itself or just about Redis Enterprise in general. We can definitely dive deeper on any of the topics and have some follow-up conversations. So thank you so much.
Thank you, Trevor. It was great to see the new Redis data integration capabilities and how they could bring Redis into an existing architecture while keeping traditional SQL databases as a system of record. And Active-Active Geo-Distribution could be a game changer where it comes to keeping Redis clusters in sync across geographical areas.